We'll calculate the forces in elements DF, CF, and CE using method of sections. Step number 1 is that we will calculate the reactions at C and B, and as we learned before, we take moments about point of intersection of two unknowns. So before we start we need to assume direction for the reactions at C and B. Reaction at C is assumed direction for reaction at C upwards, and the reaction, of course, roller will be only one reaction, vertical, and for B we'll have two reactions, one in the vertical direction and the other is in the horizontal direction, and I'm assuming directions, and we'll verify if they are right or not by getting the result. If the result is positive, then the assumed direction is correct. So this will be reaction C in the y direction, this will be reaction B in y direction, and this is reaction B in x direction. So I'll apply the rules of equilibrium to calculate these unknowns. This is unknown, and this is unknown, and this is unknown. So we need three equations, which are the equilibrium equations, but with which one we start? We said we always start at the point of the intersection of two elements or two unknowns. That will be at point B. So let's start at this point to calculate the reaction. We do the sum of all moments at B equal to 0. Let's define the direction for rotation. So with this, RCY will rotate counterclockwise, which is positive, and this will rotate in clockwise, which is negative, and 3 will rotate in counterclockwise, which is positive, and this will rotate in clockwise, which is negative. So we'll start to do the calculation based on these. So the first one is this plus, so we'll do plus RCY multiplied by this distance, which is 5 meters. Then we have this force 7.5 negative minus 7.5 multiplied by this distance, which is 10 meters. And then we have this, which is negative, so minus 4 kilonewton multiply the distance from here is equal to 15 meters. And then this is positive plus 3 kilonewton multiplied, this is the distance, which is 4 meters, is equal to 0. And from this we get, if you isolate RCY, is equal to 75 plus 60 minus 12 divided by 5, and this is equal to 123 divided by 5, and is equal to plus 24.6 kilonewton. That means the assumed direction for RCY is correct, and it is upwards, so this is the direction. So we get the value for this element. So this is now equal to 24.6 kilonewton. Now the same way we'll do the calculation for, we'll do the sum of all forces in y direction equal to 0. And in this case we have plus RCY, which is plus 24.6, and we have minus 7.5, we have minus 4, and minus RBY is equal to 0. So if we bring our RBY to this side, then it becomes RBY is equal to, so this is 13.1 kilonewton is equal to RBY. Now we'll do the sum of all forces in x direction equal to 0. And we have only this force, which is minus RBX, and this force, which is plus 3, is equal to 0. So RBX is equal to 3 kilonewton. Now I'll go and update our sketch. So this one and this one, so we'll update them, and they are RBY is equal to 13.1 kilonewton, and RBX is equal to 3 kilonewton. We calculated the reactions for this truss, and now we'll move on to calculate the value of forces in elements DF and CF and CE. And with the method of section, we'll cut a section through these elements which we would like to calculate, like so. So this will be the section that we'll be using. So let's move on to the sketch in which we broke the section into the structure into two parts. And now it is time for us to choose which part to work with, because working with each of them, each or, will give you the same results, but you always choose the part that has less amount or number of forces, because it's less amount of work. So in this case, if you look at this part and count the number of forces we have, so we have 1, 2, and 3. And if we look at the right hand side, you have the same number of forces, 1, 2, 3, so it doesn't matter, either or will do. So we'll choose one of them for our calculation. So but before we move to the calculation, we need also to learn something about the convention of direction of the forces, and let's revisit this. Normally the force that is going away from the structure, because now if we say we're considering the structure on the right hand side, so this is the element that we are considering, right? So any force that is going away from the structure, like this one, means tension, it is pulling it. And any force that is going towards this structure, okay, this is structure, right? So anything going towards the structure is compressing it, it is compression. And any force going away from the structure, it is pulling it, it is tension. So we should keep that in mind. These are the rules of method of section for the direction of forces. So now that we have a convention, we'll move to start to do the calculation now. Now before we start to do the calculation, it might as well be important for us to assume direction. So we need to assume directions for the forces. So we say for this, we'll assume this is, as we have learned, that the force that goes away from the structure is tension. So I say this is a tension force, and we assume this force is going, say, towards the structure. So this is a compression force. And let me assume this force also is going towards this structure, and this is also a compression force. So this is my suggestion, but you might ask, as why did I have these directions? It is up to you, because we said always in statics you assume directions, and after that you will, when you calculate, if your results are positive, it means you assume directions are correct, and if you get a negative result, means that the assumed direction is wrong, so you just reverse the direction. Very simple. Now the second rule in the calculation of method of section is that we have these three unknowns. This is one unknown, this is one unknown, second unknown, and this is third unknown. We know from previous lectures that we take moments about a point of intersection of two unknowns, and by doing so this will cancel out these two unknowns for us, and we'll follow the very same rule here also, because we have in the case of DF and CF, they meet at point F, which means a point of intersection. So we'll take moments, sum of all moments about point F. We'll cancel these two unknowns and we'll calculate this unknown, and then we go back and take the moment about the intersection of these two forces, meaning C, and we calculate the value of this unknown, because these two intersect at C. So we'll follow this, and after that, once we calculate the value of this and get value of this and value of this, they will have only this value left for us. For this one, we can use any equilibrium equation regarding the forces in x direction or equal to 0, or the sum of all forces in y direction equal to 0. I'll explore either one, and we get the value for these three elements by this method. So this is in brief what we intend to do and the method of section. So we can start to taking the sum of all moments about point F here. So sum of all moments about point F is equal to 0. This is an equilibrium equation that we'll be following. And before we start to do the sum of all sum of all moments about certain point, we need to define the rotation direction for each force. So we are taking this about this point. So for this point, these two unknowns will be cancelled. We don't need to bother about these two for now. We have this force valid, so we need to know what is the direction for this force, how it will rotate. It will rotate about F clockwise, so it is negative, and this force will rotate about F clockwise again, it is negative, and this force will rotate counterclockwise, which is positive, and this one will be passing through the point, so it will not cause any rotation, so it will not be considered. So now we can go back to our calculation that we have the rotation direction. So starting with this one, which is minus, so it is minus CE multiplied by the distance between CE and F is 4 meters, by 4 meters. And then we go to this one, 24, it is minus 24.6 kilonewton multiplied by distance between this force and F is equal to 5 meters. Then we have this force, which is positive, so plus 13.1 kilonewton multiplied by the distance between this and this is equal to 10 meters. 10 meters is equal to 0. So we'll just isolate the CE and see how much the value is. So minus, this is equal to 123 plus 131 is equal to 4 CE, and CE is equal to 8 divided by 4 is equal to 2 kilonewton. Now we get the answer is 2 kilonewton. Would like to know what is the type of the force, because this matters to us. So let's go back and see what CE was assumed to be. CE was assumed to be going towards the structure, so it means it is compression. So we'll say, and the answer is positive, so it means the assumed direction is correct. So we'll say this is a compression force. So I mean CE has a value, a magnitude of 2 kilonewton, and it is a type of this force is compression. Now let's do the sum about point C, because that is the other point of intersection of two unknowns. So this unknown and this unknown are intersecting. So I'll take moments about this and calculate the value of DF. So the sum of moments about point C is equal to 0. So we need to again to define the direction for the of rotation for each force. So we'll do that. So the rotation direction, of course these two forces would not cause any rotation because they are passing through the point, so these will not be considered, and the sum of all moments above c equal to 0. This one will be considered. This force will rotate clockwise, which is negative, and this is passing through the point, will not be considered again, this one. And then this one will be rotating counterclockwise, which is positive, and this will be counterclockwise also, so this will be also positive. So now that we know the direction of the forces, we'll start the equation. Starting from the first one, which is this one, that is minus df multiplied by the distance between this and this is equal to 4 meters. And then we have this one, positive 13.3 plus 13.3 kilonewton multiplied by the distance is this much, which is 5 meters. And this is also positive, 3 kilonewton is also positive, so plus 3 kilonewton. The distance between the 3 kilonewton and c is equal to 4 meters, is equal to 0. So let's see what the value, we'll calculate the value. Actually, we can take this to the other side, so 13 point multiplied by 5 is equal to 65.5 plus 12 is equal to 4 df, and df is equal to 77.5 divided by 4, and it is equal to 19.38 kilonewton. Again, if you have noticed, the answer is positive, so it means the suggested direction is correct. So let's see what the suggested direction for df is. The suggested direction for cf is tension, so it means this is a tension, so we'll mark this as tension. So we have this force to be a tension. Now what's left for us is this force, so we'll need to do the sum of all forces in x direction or y direction equal to 0. So let's do this. So now we have this value calculated, this value calculated, compression tension. Now this one is resolved into x and y, so now we can do either the sum of all forces in x direction equal to 0 or the sum of all forces in y direction equal to 0. The choice is ours. We'll choose the sum of all forces in y direction equal to 0. And with this one we'll have this one involved, which is downwards, so minus 13.1. and we have this one is upwards, plus 24.6 kilonewton, and then we have this component of the unknown is downwards, so it is minus CFY. Minus CFY is equal to 0. So this is the equation. So from this we get, we'll bring this to this side, so this becomes 11.5 is equal to CFY, and 11.5 is equal to CF. CFY is equal to CF multiplied by sine 3866 degrees. So CF is equal to 11.5 kilonewton divided by sine of 38.66 degrees, and CF is equal to 18.4 kilonewton. And again, if you notice, the sign is positive, so we have to go and see what we suggested for CF. We suggested for CF going towards the structure, it means it is compression. So I'll mark this as this force as compression force.